How many electrons are transferred in the formation of beryllium fluoride? 1 electron, 2, 3, or 4 electrons? Now there's quite a bit to dissect from this. One, the fact that beryllium fluoride is an ionic compound, as it's composed of both positive and negative ions. And if it's an ionic compound, we know that by definition, it's got to have a zero charge overall, a neutral charge. We add up the charges of our ions and we get a net charge of positive 1. But hold on a sec, that's not a neutral charge. So where does that leave us? We need to do what we can to make the overall charge 0. And in this case, it means that we have 2 fluoride ions to balance out the charge and add to an overall charge of 0. And now we have beryllium fluoride, BeF2, composed of a single Be2+ and a pair of F- ions. So with this new information, let's circle back to the original question. How many electrons are transferred in the making of BeF2, beryllium fluoride? Well, that boils down to the formation of these ions. For instance, we have one Be2+, that's because we took away 2 electrons from a single atom of beryllium. For fluorine, we added a single electron to become F-, and we did that for 2 separate atoms to make 2 separate F-. But does that mean that we transferred 2 electrons in total, or 4 electrons to make BeF2? This is a more big picture view of the electron transfer that's going on. Each of the F atoms take a single electron from a Be atom. In other words, the 2 electrons that the beryllium atom loses are the same 2 electrons picked up by the fluorine atoms, 1 each. Therefore, beryllium fluoride needs 2 electrons transferred to be made.